All right, example number 3 continued. So we need to figure out our first factor. So I'm literally going to start trying like p of positive 1. Well, p of positive 1 does not give me a remainder of 0. So I'm going to go to the next one, p of negative 1. So p of negative 1, by substituting negative 1 into my polynomial, we end up with 0 as a remainder. So this tells me that x plus 1 is a factor. Okay. All right, so that's one of my factors, but potentially this polynomial is going to have 3 factors because it's a degree of 3. So now that I have one of my factors, now I'm going to take this factor and I'm going to divide it into my polynomial. So using synthetic division, I'm going to divide this into my polynomial. And I'm going to start to divide. So drop our 1 down, multiply, add, multiply, add, multiply. And because we know this is a factor, when I divide it, I should end up with a remainder of 0. If I don't, then I've made an error somewhere. So what does this tell me so far? It tells me that x plus 1 is a factor, and then when I divide this into this polynomial, I get a quotient of x squared plus 2x minus 15. So now that I'm left with just a quadratic expression, now I can go further and just factor this like I normally would. So completely factored form would be x plus 1 is one factor, and then the factors of this quadratic would be x plus 5 and an x minus 3. So this is my completely factored form. And so that is how you factor a polynomial with a higher degree than 2. Okay? So this one I've asked to try on your own, so I'll just quickly run through it. Again, I'm going to look at the negative 24. I'm going to, in my head or just on the side, I'm going to kind of list all my possible factors, which seem to be a lot. Right, so these are all the possible factors that could factor into this. And again, I'm just going to start, usually like one of the first 4 tend to work. We're not going to give you something where you're trying, 20 different numbers to finally get your first factor. So I do know that p of negative 1 works. So p at negative 1 gives me a remainder of 0. I am now, which means x plus 1 is a factor. So now I'm going to divide negative 1 into my polynomial. Okay, a little bit bigger. And this is x to the 4th, so we're actually going to have to do an extra synthetic division to, sorry, this should not be negative 1. I'm a little bit too fast here. So drop down, that's a 1. Multiply negative 1, we get a 3. Multiply, add, we get a negative 10. Multiply, add, we get a negative 24. And we should end up with this remainder of 0. Okay, so now we're kind of back at the drawing board, because what we're left with is we're left with a factor of x plus 1, and then we're left with an x cubed plus 3x squared minus 10x minus 24. So because this is a cubic expression, we can't just break this down and factor it yet. So again, we have to try the factors of negative 24 again in this polynomial to find our first factor. And the one that I know that works is p at negative 2 gives us a remainder of 0. So now I'm going to factor or divide negative x plus 2 into this polynomial. So negative 2, this would be a 1, a 3, a negative 10, a negative 24. Drop the first value down, multiply, add, multiply, add, multiply. All right, so now we are at our final stage. So we have x plus 1 as a factor. We have x plus 2 as a factor. And now we're left with our quadratic, which we don't have to use synthetic division again. We can finally just factor this using the method we've used in the past. So factors of negative 12 that add to 1 in the middle would be x plus 4 and an x minus 3. So fully factored form would be so. So there should be 4 factors. All right, let's move on to example number 5. A garage is built in the shape of a rectangular prism. The volume V of h can be represented by the expression h cubed plus 9h squared plus 24h plus 16, where h is the height of the garage door. Factor the expression. Okay, again, I'm going to look at 16. All my possible integral zeros are the following. So I'm going to start by trying each of these, and I come across that negative 1 works. It gives me a remainder of 0. So to factor this, I'm going to divide negative 1 into my expression using synthetic division. You can divide these each using long division if you choose. I just find synthetic division is obviously the quicker method. And I get a remainder of 0. So then my factor would be h plus 1. And then I'm left with an h squared plus 8h plus 16. So fully factored would be h plus 1 and an h plus 4 times an h plus 4. Okay, what does each factor represent with respect to the expression? Okay, so technically h is the height of the volume V of h can be expressed by the following expression, where h is the height of the garage door. So technically these would represent our length, our width, and the height of the garage. So remember, h is the height of the garage door, right? These would represent the actual dimensions of the graph, or the garage. If the height of the garage door is 2 meters, find the dimensions of the garage. Well, I simply substitute 2 in for my height. 2 plus 1 is equal to 3. 2 plus 4 is equal to 6. And 2 plus 4 is equal to 6. So the dimensions are a 3 by 6 by 6 meter garage. Okay. All right, moving on to example number 6. It gives us the polynomial kx cubed minus 10x squared plus 2x plus 3 has a factor, keyword here, factor of x minus 3. So if it's a factor, that tells me that the polynomial, when I divide or substitute 3 into my polynomial, should give me a remainder of 0. So as soon as you see that word factor, if this is a factor of the polynomial, then I know the remainder has to equal 0. So now I can substitute in 3 for my x value, and it can equate it to 0, and then I'll be able to solve for k. So k times 3 cubed minus 10 times 3 squared plus 2 times 3 plus 3 is going to equate to 0. This all equates to 27k minus 81 equals 0. Divide by 27, my k value is 3. Excuse me. So key, that factor means remainder equals 0. Okay, and then taking it one step further, algebraically solve the following polynomial equation. So as soon as we take a polynomial and make it equal to 0, after we've factored the entire polynomial, we want to go one step further and actually solve for x, solve for x values. Okay, so my integral zeros of -9 would be plus or minus 1, plus or minus 3, and plus or minus 9. So again, I'm going to try all of these possibilities. And I find that p at positive 1 works. Gives me a remainder of 0. So I'm going to divide, using synthetic, divide 1 into my polynomial. Drop the 5 down, multiply, add, multiply, add, multiply, add. So what I end up with is I end up with a factor of x minus 1, a 5x squared minus 46x plus 9 equals 0. So I need to make that equal to 0 still, just to remind myself that I'm actually solving for x. So now I'm going to factor my quadratic using Lecky method. Well, I'm going to draw two binomials. I know the factors of 5x squared had to be a 5x and an x. Because this middle value is fairly big, I'm kind of thinking, well, I probably have to multiply my 9 by my 5. And because this is a positive, I'm thinking like I need to add all the values in my head. So 5, if I multiply this by 9, I get 45x. And then the factor that's left over is just 1. I get 1x. If I add these up, I'm going to get my negative, I'm going to get 46. That also tells me that both of these factors would have to be negative. All right, so there's my factors. I'm not quite done, so I've factored this fully. Now I need to solve this. So to solve each factor for x, right, I take the binomial, make it equal to 0. So I get here, I'd get a value of positive 1. Here I'd get a value of 1/5. And here my x value would be 9. So my solutions to my polynomial equation would be 1, 1/5, and 9. And that is the factor theorem.